This video covers section 11.3, logarithmic functions, objective 3, evaluate logarithmic functions. To evaluate logarithmic functions, we need to think of them as their inverse problems sometimes. And so remember, we have the equivalency between x equals a to the y and y equals log base a of x. So when we're asked to evaluate a logarithmic function, we want to think of these in terms of their equivalent exponential problem. And so for that reason, I remind you the exponential problems. 2 to the x equals 32. We solve these by saying 2 to the x equals 2 to the 5th, or x is equal to 5. So if you think about what we just did there, we took a problem in exponential form and we solved it, but the logarithmic form for this would be x is the exponent on my base 2 to get 32. So we would now say that the log base 2 of 32 is 5. Every exponential problem has its equivalent logarithmic problem. Letter B says 4 to the x equals 1/16. The left side is base 4. The right side is base 4 as well if I use a -2, giving us x is equal to -2. So in terms of an exponential statement, x is -2, but in terms of a logarithmic statement, x is the exponent on my base 4 to get 1/16, and we just said that that exponent is -2. So the log base 4 of 1/16 is -2. This is the logarithmic statement, and this is the exponential statement. That is how we will deal with evaluating logarithms. So when I see something like log base 3 of 27, I'm thinking of this as some number that I would raise 3 to get 27. We're going to take these and convert them into their exponential statement, and we see that 3 to the x is 3 cubed, or x is equal to 3. So that tells us that the log base 3 of 27 is equal to 3. And we say that's because 3 cubed is 27. The exponent on the base is equal to 27. So if someone asked me what the log base 3 of 1/81 is, I would think of this in terms of its equivalent exponential statement. 3 to the x is equal to 1/81. The right side is 3 to the -4th, giving us x equals -4. So we've just determined then that the log base 3 of 1/81 is the exponent on 3 to get 1/81, which is -4. And again, that's because 3 to the -4 is 81. So here are 2 practice problems for you to try. I encourage you to press pause on your video and work these out, and come back when you're ready to see the solution. Now that you've had a chance to work these out, I'll work these out with you. Log base 5 of 125. So I'm thinking, what number would I raise 5 to get 125? And I know that 5 cubed is 125, so I get x is equal to 3. So the log base 5 of 125 is 3. Log base 2 of 1/8, we think of that number as the exponent on 2 to get 1/8. The right side is 2 to the negative 3, which gives us x equals negative 3, or the log base 2 of 1/8 is negative 3. So again, remember logarithms. When finding logarithms, we're finding the exponent on the base to get the number inside. All right, so evaluating logarithmic functions, just like with square roots, we like to have perfect squares under them. Cube roots, we like perfect cubes. In logarithms, we want to plug in numbers that have the same base as the logarithm, so base 2. So you have to be clever about which numbers to plug into these if you're given the choice, but these have been set up for us. F of 16 is the log base 2, where we see x is next to that, so log base 2 of 16. So in your head, you need to be thinking, what would you raise 2 to? What power on 2 gives us 16? So 2 to the 4th power is 16, giving us f of 16 is 4. One 32nd is also a power of 2, so that's the log base 2 of 1/32. So I'm thinking, what would I raise 2 to get 1/32? I know that 2 to the 5th is 32, so that 2 to the negative 5 is 1/32. So this will give us negative 5, telling us that f of 1/32 is negative 5. These kinds of function evaluations are setting us up so that we can graph a logarithmic function. Now, be very careful with letter C, f of 0. It's asking for log base 2 of 0. Your instincts might be to say that that's 1. But we are asking for the exponent we would place on 2 to equal 0. 2 to the 1st is 2. 2 to the 0 is 1. 2 to the negative 1 is 1/2. This is undefined. This we cannot find because, as we've been saying, 2 to the x is always greater than 0. So there's actually no solution, or you can just say it's undefined. We cannot plug in a 0 into a logarithm. And this leads us to 4 practice problems for you to try. I encourage you to press pause in your video and work these out, and come back when you're ready to see the solution. Now that you've had a chance to work these out, I'll work these out with you. So notice this time our base is 5. So we want to plug in numbers like 5, 25, 125. F of 25 is the log base 5 of 25. We're thinking, what number would I raise 5 to get 25? And we see that that has to be 2. Log base 5 of 25 is the exponent that I place on 5 to get 25, giving us f of 25 is 2. If we do 1/25, then that's the log base 5 of 1/25. I'm asking myself, what power would I raise 5 to get 1/25th? Because it's a reciprocal, the output to this needs to be a negative number, and 5 to the negative 2 is 1/25. And now if you plug in a -5 into a logarithm, you're asking for the log base 5 of a -5. We're thinking 5 to what power gives us -5? But 5 to any power is always greater than 0, because the range of the exponential function is greater than 0. So there's no solution to this, or undefined. So you can't have a 0 in a log, and you can't have a negative inside a log. They're undefined. So you can't have a 0 in a log, and you can't have a negative in a log. They turn out to be non-real numbers. So we're setting up the domain of a logarithmic function. The numbers you can plug into a log are greater than 0. Not less than or equal to 0, greater than 0. So that's the domain of our logarithmic functions. We can plug a 1 into our logarithms, however. That's the log base 5 of 1. And this is 5 to the what power gives us 1. And we see 5 to the 0 is 1. And so this is equal to 0, or f of 1 is 0. This is actually true for any base you give the log. Log base 7 of 1 is 0. Log base 8 of 1 is 0. And that's because any number raised to the 0 power is 1. So that will be a property of our logarithms that we'll state in subsequent videos. So the major takeaway from these two examples is that you cannot have a 0 in a log or a negative in a log. And further, you want to plug in numbers that have the same base as the base on your logarithm. And this concludes the video for section 11.3, Logarithmic Functions. Objective 3, evaluate logarithmic functions.